Hi, so in this video we'll talk about the calibration in ultrasonic testing method. We'll also be talking about the basic step-by-step process of how to perform this ultrasonic testing method. So let us talk about the calibration. So the calibration of the probe which is used in ultrasonic testing method is important because after using it for a couple of months or after using it for a certain period of time, it starts to give false false readings and inaccurate values. Okay, so it's really important to fix the probe. Now, how would you calibrate a probe? So in order to calibrate this probe, what you need is a material something like this. Okay, this is called the V1 block. You also have V2 block right over here, but in this video we'll only be focusing on this one, this V1 block. So on the prefix you can see that it's written IIW. IIW stands for International Institute of Welding. Now this is a regulatory body which manufactures all these kind of blocks, right? So mind you, this block is made of steel, okay? And as you can see that there are so many different types of dimensions. The thickness is 100, the length is given as 300, and this distance right over here is given as 90 mm. And also this diameter over here is given 2 inches. So now, what are the things that you need to perform this calibration? The first thing that you need is this V1 block, and the other one is a probe, the probe which needs to be calibrated, and also you need a screen, something like. So in this, for the sake of the video, I'm going to be using the cell phone as a screen or monitor. So this monitor is also known as the flaw detector, right? So this monitor, what it basically does is that it shows you a graph. Okay, it's almost like a graph paper, which I'm sure you must have seen, seen outside. So this is basically the virtual graph paper. So now, before starting the calibration, you first need to find out the range, right? And in this case, as you can see, the thickness is given as 100. The range is nothing but 0 to 100. The range is nothing but it is the lower and the upper limit. Okay, so it has to be 0 to a certain value. In this case, it is 100. In this because the thickness is 100. If the thickness was maybe 200, then the range would be 0 to 100. And likewise, you need to find your own range depending on the size of the size of this specimen. So what you need to do is that you place the probe somewhere over here, right? You place the probe, and what you do is you send the sound waves. So once the sound waves passes from here to here, the top to bottom portion, and the sound wave reaches the bottom and it comes back again. So if the probe is doing okay and if it's right, then you'll find no error in readings. You'll find that you'll find the range on the screen as 0 to 100, and you'll get all the correct readings, right? But the problem is if instead of getting 100, okay, on the screen, okay, instead of getting 100, if you're getting a value something like 97.6 or 102.5, 103, etc., anything but 100, you should know that the probe is faulty and it needs to be calibrated. So okay, so now that you've understood this one, if you need any more some more clarity, then you can also, instead of placing your probe over here, you can also place your probe somewhere over here. Yeah, so now in this case, let me ask you, what do you think will be the range? Will it be 0 to 100? No. In this case, the range is going to be 0 to 90, because the thickness of this portion right here is given to be 90, right? So this is how you do the calibration part. Now let's talk about the basic steps on how to perform this experiment. So the first thing is the phase is called the preparation phase. you need to take the specimen and you need to clean the specimen. Okay, you need to even wash it and apply some oil or glycerine. This enhances the sound waves this propagation. The second part will be the setup. Take the material, take the specimen right here like this, and take a probe and place it directly perpendicular on the surface. On the surface. Now this is the second portion, which is the setup. This is the setting up phase of the testing method. The third phase would be the testing method. In order to test this method, you need to send the sound waves. Okay, the sound waves needs to reach all the way from top to bottom, and it should come up. So if you want to understand it more deeply, then I'm going to show you in the form of a diagram. Now in this case, you can see that there are two different cases, right? Case 1 and case 2. So, and correspondingly, you can see that there are two different types of screens. This is screen for case 1. This is the screen for case 2. So in case of case 1, since there are no faults, you can see that there are no faults over here. So the sound wave passes all the way from top to bottom, and then again it comes from bottom to up. And correspondingly, you can see that there is a curve at the beginning and a curve at the back. This is called the back wall echo. So this shows that there are no defects, right? Because in the mid section you can see that there are no curves. So this shows that there are no defects present. But in the second case, as you can see, that there is a defect somewhere over here, right? So and also correspondingly, you can see that the sound waves are much smaller. The distance is much smaller, right? And correspondingly in the screen of the for the second case, you can see that there is an additional curve somewhere like this. And this additional curve right here, it shows that there is some kind of a flaw or a defect, and this is how you find out the defect in this specimen which we are testing. So this was all about the testing method. Now let's talk about the fourth phase, which is the analyzing. Once you've found out the defects and any sort of flaws, the fourth point is that you need to analyze the defect. Like what type of defect it is, what is the location, and also what is the size of the defect. These are very important parameters to be taken into account. And once you find out the defects, you need to note down all of the defects and make a detailed report. So the point number 5, the final phase of the testing method is the report making. So once you're done finding all of the defects, you jot down all of the flaws, and then you place it one after the other. And what you do is that once you get the readings, you take the values and compare it with the given values, which is the acceptance, which is also known as the acceptance criteria. So once you know that the values are within the acceptance criteria, you make a detailed report, including the name, including what kind of defect it is, what kind of parameters, and then you need to take further action. So I hope the video was quite helpful, and I will see you in my next video. Thank you so much.